Bismillahirrahmanirrahim. Well, let's start. Let's continue talking about data modeling using the interrelationship diagram. Recall, last time we have discussed a few issues about the ERD. We said that ERD is a language. It's a language like any other language, has its own vocabulary. The vocabulary of ERD is composed of entities, or let's call it entity types, attributes for these entities or entity types, and relationships, or actually let's call them relationship types. So we have three components, three elements of the vocabulary: entity types, attributes, and relationships. Last lecture we have discussed both the first two elements, the entity types and the attributes. We say an entity type is a type, like any type. A student is an entity type. Has attributes? Yes, it has attributes. It has student ID, student name, address, telephone number, date of birth, and so on. So these are the attributes of the entity type. Student is an entity type that can have occurrences. So Ahmed, Muhammad, Ali, and so on are occurrences of the entity type. They are occurrences they take whose attributes take values. So when we say Muhammad is the name, is the value of the name, of the attribute name of the student entity type. So we differentiate between an entity type and entity occurrence. Then we move to how to represent the entity type in an ERD. We said we use a box like this, a rectangle with a name. Every entity type has a name. The name is usually singular: staff, branch, and so on. Now, what about the attributes? We have the attributes and classify the attributes into simple, composite attributes, something like address. Address is composed of street, city, state, zip. So this is a composite attribute that is composed of many components, many parts. It's not one single part. So we have simple attribute versus composite attribute. Also we have single valued attributes versus multi-valued attributes. Single valued attributes are those attributes that take only one value, while multi-valued attributes can take many values. We gave examples: the telephone number for a department, for example. Telephone with a department may have many telephone numbers. So this is a multi-valued attribute. A third classification of the types of attributes is derived attributes. Derived versus non-derived, or derived versus given. So an attribute could be a given value, a value that we cannot deduce from other values, or it can be derived from other values through an equation. And we gave example for this, the GPA. The GPA of a student is a derived attribute. Why? Because it could be computed using the marks he has obtained in all of the courses he has studied. So we have simple versus composite, we have single valued versus multi-valued, and we have derived versus non-derived or given. We move then to okay, one thing that I like to add or to stress on, that each attribute has a domain. Each attribute, let me go back here, and we say that each attribute must have a domain. We cannot compare apple by orange. We cannot compare a student number by the GPA. A student number or a student ID is of a domain different than the domain of GPAs. So we cannot compare this to that. So the domain is a type of the attribute with all the constraints defined on that attribute. this makes it easy to compare, makes it easy to validate the value entered for this attribute to make sure that it is within the limits, within the constraints defined for that attribute. So every attribute should have a domain defined for it. Now we moved also to define what we called it the keys. The keys. So how to identify a student, how to point to a student, specific student, Ahmed. So of course Ahmed is just a short name, but how to, when you go to anywhere in the university, for example, the first thing they ask you is what is your ID number. So the ID number is your identifier. This is a unique number, so the most important property is the uniqueness. So it is a unique number that is through which we can identify one and only one entity of that, or actually entity occurrence in that entity type. So every entity type should have a key. A key is a unique identifier through which we can pick, we can identify the specific occurrence. We have different types of keys, or actually all unique identifiers are called candidates. Candidates for what? Candidates to become a primary key, or all are valid keys. Every unique identifier or set, every unique identifier, or actually every field that satisfies the uniqueness property is called a key. Maybe one single field, or maybe a composite key having many components, many parts, but it is so it is a candidate key. One of these candidate keys will be selected or chosen to become the primary key. All the others will be called alternate keys. So we have one single primary key for every entity type, and many alternate keys if there are any other keys. So the keys again, super key, candidate. Let's forget super key for now. We'll discuss super key later on. Candidate keys, all unique identifiers are called candidate keys. One of them is selected to become the primary keys. This is the one that's most commonly used to identify the entity, specific entity occurrence. We said we have for a student, for example, we have student ID, student name might be a unique identifier. Maybe other fields or attributes can play the same role of unique identifiers, but we choosing the primary key. We choosing the student ID as the primary key. So everywhere you go, they will ask about this unique identifier, this primary key, the ID, the student ID. All the others are also possible unique identifiers, so we can use them when the primary key is missing. When we don't know the primary key, we can use these other keys. So we call them alternate keys, or sometimes they are called secondary keys. We move then to differentiate between an entity type and an entity occurrence. For example, this is an entity type. This here is an entity type, car, and these are the attributes of the car, and this is actually we have different representations for each type of attributes. So simple attributes are just ovals like this, year and model. Simple attributes. Composite attributes are defined like this. So we have the registration is split into two parts. That's why we call this attribute as a composite key. A multi-valued attribute has a double-edged oval like this, the color. We don't have here derived attributes, but anyway, derived attributes are drawn using a dotted edge oval, dotted. This is an entity type car. We have many cars in our garage. So we have car 1, car 2, car 3. Everyone has specific values for each one of these attributes. So we call this, every one of these, car 1 is an entity occurrence. So car in general is the type. It is the entity type. While car 1 is an entity occurrence. Entity occurrence because every one of the attributes of the type is given a specific value. So we have car 1, car 2, car 3 with specific values for each of the attributes. We call this as the set of cars, the set of occurrences. So this is the occurrence set, this is the type. Okay, our entity set or occurrence set. Now let us move to, this is another example of a type, employee type and the company type. The employee has name, age and salary. The company has name, headquarters and president. And these we have two companies, so this is the company set or the entity set for company. This is the employee set or the entity set for employees. Let's move to an important another element of the vocabulary, the relationships. We said that the vocabulary of the ERD language is composed of three main components: entity types, attributes, and relationships, or actually relationship types. So let us move to the relationship types. This is the subject of today's lecture. Let me move to a simpler example. This example is good. We have a staff, we have branch, and we have staff. And the branch has this set of stuff, many stuff. Or let's say it another way, a staff works for a branch. Every staff works for a specific branch. So how to represent this relationship? Remember when we talked about the informal description of the data requirements, informal description, we wrote the relationship in terms of a readable statement, a statement having two nouns and a verb. So here are two nouns, branch and staff, and there is a verb that makes the relationship between them. It is the verb that when we read the sentence, it gives a meaning. It's a meaningful sentence. So an ERD says many things. It's a picture, but it says lots of things. So let us try to find how to read this diagram. We have branch. The branch has staff, right? Branch has staff. Is it a meaningful sentence? Yes. It says that a branch has or contains or has employees that work for it. What are those who work for it? Staff. So we have a branch has staff. Let me ask a question. Is the branch has the staff or the staff has the branch? The branch has the staff. Staff works for a branch. That's something different. So since I used the word has to label the relationship, to label to as a name for the relationship, so we need to be very specific about the direction, how to read the sentence. So because in diagrams you can draw the box for example for staff to the right or to the left, up or down, anywhere in the paper, right? So there is no rule that says staff has to be to the left or branch has to be to the right. So let's have a convention, because you don't know how to read. Notes that the relationship is represented in terms of a line, The relationship staff is an entity type, branch is another entity type, and they are related together with a relationship, so we draw a line, just a line, no arrows. So how to read this? And this line has a label, has a verb. Its name is a verb. So now, how can I read this sentence? What is the meaning here in this statement or this sentence of the ERD? Why don't you read it staff has branch? How can you tell which one has the other? There is nothing that says read it this way or the other way around. Read it right to left or left to right. No.
But logically,
we don't care about logic because sometimes we don't know which one. It is clear in this example. Some other examples, some other verbs, you will get confused. So let us have a convention. Let's agree on a convention. Always we read the sentences from left to right. So it should be staff has a branch. But this is illogical, as you said. So if you are, because as I said, you can draw the boxes anywhere on the paper. So it happened that I find staff to the left, but I cannot read the sentence like this. Staff has a branch, because this is illogical. So if you want to use the verb as has, and you want to read the sentence right to left, opposite to the convention, just use an arrow. Arrow. Just an arrow. An arrow like this one. So this arrow, besides the verb, besides the label of the relationship, will indicate the direction of how to read the sentence. So once I see the arrow, I know that I'm going to read this right to left. If you are reading the sentence left to right, then you don't need to have an arrow. So it is by default written left to right, or read left to right. Okay? Same for up and down. The convention, let's agree on a convention. The convention is to read it from top to bottom. By default. If you want to read it the other way around, from bottom to up, just use an arrow. So let's agree on this convention. Okay? So again, we have two entity types connected together with a relationship. This composes, or this makes a very well meaningful sentence. So we can read the ERD diagram. It tells a lot of stories. It tells many things, but there is a rule for reading these sentences. Do we have in this example we have a relationship between staff and branch? The question now is, can I have many relationships that tie or relate the same two entity types? Meaning, I have one single relationship relating the staff to the branch or the branch to the staff, right? Can I have another relationship that links or relates those two entity types? Same two entity relationship types? Yes, we have. Let me show you. Here is another relationship. I have the same branch and staff. They are related twice. Don't look at those. Those are just explanations of what how can you read the diagram. But anyway, this is the entity type branch. This is another entity type staff. This is the has relationship that we have discussed a minute ago. But also we can say that this staff member, this person, manages this branch. So a branch has a manager, or the staff manage branch. Here he draws arrows just to stress on the direction of reading the sentence, but as we said, it is not needed if you are reading the sentence from left to right. This example shows that I can relate two entity types with the same, with two different relationships. One, they are related one time for has. The branch has many staff members, 5, 10, whatever. But again, the staff, one of these staff members manages the branch. Hard to understand. In order to understand, let us go into the concept, a new way of representing these relationships. Let's call it occurrence diagram. So we have entity type, so this leads to the entity relationship diagram. Let us have another type of diagram, which we call it occurrence diagram. What's the occurrence diagram? Let's go back to the relationship branch has staff. Branch has staff. Let me draw a picture. Let me draw here. This is branch. Let me use the same direction as this. So we have branch here. We have staff. And they are related through relation called as. This diagram here to the left, this diagram is called the ERD. This is an ERD. It talks about types. This type is related to that type with this relationship. Now we are talking about specific persons, specific occurrences in this occurrence diagram. So let me point using the mouse. We have two branches, B03 and B07. Assume that this is the pool in our database. This is the pool of branches, right? Yes, these are the occurrences of the branch. We have two branches. Let's assume that B03 and B07. These are the branches. Okay, B03 is the branch number for a specific branch, and B07 is the branch number for another branch. Of course, the branch number is the primary key in this example. Okay, so let's represent the branch by its primary key, the identifier. Okay, so we have two branches here in this pool, B3 and B7. And we have many staff. Let's assume 3 staff like this. Staff SG37, SG14, SA9. These are the staff number. These codes are the staff number for staff. So these are staff occurrences, and these are staff branch occurrences. Okay. Now let's assume that we are now discussing the has relationship. So what we do is just draw a link, and a line that links the branch to the staff he has, or it has, right? So we have B3 has SG37. B3 also has SG14. So if you look at this diagram, you would say that B3 has 2 staff members, while B7 has SA9, only 1 staff member. This is just a simplification, right? So this is how to relate every specific occurrence in that side with the occurrences of the other side that relates to it, that are linked together using what? The has relationship. Now let's look at the same occurrence diagram between department and employees, but for another relationship, the managed relationship. We said that staff manage branch, right? Or employee manage department, it's the same. So we have here, let me draw it here. This is another between branch and staff. We have another relationship which is managed. this time we have to draw an arrow because it is the other, it's right to left. It is the right to left. So I just draw an arrow like this. Now again, you'll find that what? Department 1 is managed by E3. By the way, you can write something like this: staff managed branch, or you can say branch is managed by staff. If you read the other way around, just convert the word, convert the verb. So I can write it is managed by. Right?
Which one is better? To use the default way or
No.
it's short?
No rule. It's up to you. The way you feel it more convenient to you, more appealing, more understandable.
I mean the common way.
Nothing. No common way. It's up to the analyst, up to the user, the way that's more readable, more understandable, more convenient to them. But sometimes people like to stick with the direction in order not to search for the line, for the arrow. Some other people want to always read it left to right, while others try not to use likes to use one single verb, one single word for the verb, not a verbal phrase, just one single word, simple verbs. So it's a convenient. It's up to you. No restrictions here. So in this example, we'll see what? That D1 is managed by E3. D2 is managed by E6 and so on. So again, I'm now mapping the same department with one single line to identify the manager. So this relationship in the middle is called the manage relationship. Right? You got it? So I can link. Let me try to draw it here. This one, let us try to draw it here. So we have two relationships, right? Here is staff. Here is the branch. And let me have here, not too much. Let's have two branches just to make it simple. This is B1. This is B2. What is B1 and B2?
Branches.
Occurrence, right? Occurrence of B2. Occurrences of the branch. This is a branch. Branch is an entity type. So these are occurrences of branch. And let me assume that we have staff. Staff, let's call S1, S2, S3, and S4. Now I have S1. Let us build, now we have two relationships, right? Has and manage. Let me use a different symbol for the relationship, not like the diagram here, just to make to differentiate between what's an entity type, what's a relationship. So let us assume that this is has. So we have B1 has S1, right? And B1, same B1 has S2. Also B1 has S3. Let me assume that. Now I have B2 has S4, here S5, B2 has S5, right? So this is the has relationship. Now can I relate the branch to the staff who manage this branch? Yes, let me have another relationship called manage, or manage it by, because if you're moving this way, manage it by, let me call it this way. So now we are V1. Who is the manager of V1? Of course, he is one of these staff, S1, 2, 3. Right? So let me assume it is S2.
like the hash.
Let me use a different color.
Right?
Now,
It should be not different than a hash relationship.
that's a constraint, yes. Yes. That's the constraint that the user will tell. Of course, the department is managed by,
The same.
there is a restriction. Now, there is a constraint, let's call it constraint. The user will tell me, I'm going to ask the user the same question you have asked it now. Does the manager have to be one of these stuff that are related using has? He might say yes, he might say no. It depends on the rules of this company, of this menu word. Sometimes they restrict that yes, he has to be one of these staff members. Sometimes not. I'll give you an example. Here in the college, in our college, sometimes who manage the department, the chairman, the department chairman, does not belong to the same department. Might be coming from some other department. So he will work in that department, for example, IT, and manage the CS department. This depends on we call it the business rules, the rules of the menu world. Okay, but let me assume that it is in our case here, it is one of them. Now B2 is managed by, let me assume it's S4. So this is the occurrence diagram for the ERD drawn up there, right? Why I did this drawing? Because in order to show that we have two different relationships. Look at B1, for example. B1 is linked twice. One in red and one in black. Two elements of the stuff, two occurrences of the stuff, right? Link it to the occurrence of the stuff twice. One in red and one in black. The black says those stuff are working for it, right? He has them.
Has those stuff.
Huh?
Those branches has.
This branch, yes, this branch has those stuff. However, the red says that this branch is managed by these stuff, the different. Okay. So now I'm coming into a point. Now let me ask you a question. These are what? Occurrences of branch. These are occurrences of stuff. What are these?
Relationships.
This is the relationship. Has is the we said branch is an entity type, right? So B1 and B2 are entity occurrences. Entity type, entity occurrence, right? Now, what is this has and what is this black arrows here, black lines here?
Relationship occurrence.
Exactly. So this is a relationship type. Why? Because these are the occurrences of the relationship. Same as we did for the entity type. Right? This is specific point here is relating what? Relating B1 to S1. It's not relating B1 to S2. It's not relating B1 to S5 or whatever. It's relating B1 to S1. One from here and one from here. Which is different than this other occurrence here. Relationship occurrence. Because it relates B1 to S2 and so on. So let us now, as we have done with the entity types, we have entity type and entity occurrence. Similarly, we can have relationship type as managed by, this is a relationship type, and these are the relationship occurrences. These are the occurrences. These are the specific links that link one from here and one from there. This is the relationship type, and this is the relationship occurrence, exactly as we did with the entity types. What we care about is not the occurrence diagram. What we care about is the ERD. The ERD is the conceptual model. We just draw this occurrence diagram. As you see, we haven't used names, specific names. We gave some just symbols, just to get an imagination, just to imagine how the how it works exactly. At the point. Very good. Now, let us go back to our occurrence diagram because it's going to simplify another issue. Now we have employee managed department in these examples. You will find what? That everyone in the let me call it another way. Look at the relationship type. The relationship occurrence, I'm sorry. The relationship occurrence, R1 and R2 and R3. You will find that R1 is linking E3 to D1, right? Look at D1 and count how many lines going out of D1. Only one. Meaning that D1 is not related to more than one of the employees, according to the relationship manage, right? Look at the other side. Let us look at E3, for example. E3. How many lines coming out of E3? Which means that E3 is related to only one department under the relationship manage. So, looking at one side, the department, only one link goes out, right? From each entity. And employee, only one link goes out from that side, right? We call this one-to-one relationship. One from this side is linked to one from that other side. Got it? One from this side linked to, that's why we call it 1 to 1. And we write it this way. One, something like this. We write it this way. 1, 2 points like this, and 1. This is what we call it the relationship type. So now we talked about the relationship types, relationship occurrences, and now we are going to classify the relationships to their type. So we say this relationship is of type 1-to-1. Relationship of type 1-to-1. Okay? So do we have any other types? Yes, of course. Look at this one. The employee works for a department. While the department, so the employee works only for only one department. Why? How can I tell? Because the employee has only one link going out of it. Look at any of these employees, only one link going out of it. While the other side, department, may have many arrows or many links going out of it. D1 has 3 employees working for it. D2 has 2. D3 has 2, and so on. So from this side, only one link goes out. From the department side, many. We call it many because anything greater than 1, we consider it as many. So 1 to many. So this relationship is of type 1 to many. We write it like this. We don't care which one is the one, which one is the many, which side. Because as we said, you can draw it the other way around. Diagrams, there is no restriction where to draw employee, whether to the left or to the right. So we don't care, but we always write it like this, 1 to many. Regardless which is the one, which is the many. Some people use 1 to n instead of m.
Yes.
Some others use 1 to star instead of m, which means many as well. So all of these are acceptable abbreviations. So we have one-to-one, one-to-many, and many-to-many. Look at this diagram. Works on. So an employee works on project. Now it's a project, not a department. So this says that E1 works on P1, but E2 works on two projects, P1 and P4, right? Look at E2. E2 works on P1 and P4, right? So some of the employees have two links going out of them, are linked to two elements, two occurrences of project. Look at the project again. Project P1 has two employees working for it. P3 also has two, and so on. So we have many from this side and many from that side. So we call this relationship many to many, M to M. Again, some people write it N to N or star to star. But I stress here on that the two dots are vertical, not horizontal. Okay. Horizontal has different meaning. We'll see the horizontal one later on. Okay? When you say it vertical dots, it means that it is a relationship type. The type of the relationship. One-to-one, one-to-many, and many-to-many. Now let's talk about another description of the relationships. The relationship degree. We have relationship type, one-to-one, one-to-many, many-to-many, and the relationship degree. We used to draw, as here, we used to draw the relationship as a single line, right? Which means that these two entities are related with this single line, with this relationship. The degree of this relationship is called binary degree. Why binary? This has, for example, has relationship is a binary degree. The managed relationship is a binary degree. Why it's a binary degree? Because it links two entities together. Or actually two entity types. Two. So it's a binary. Binary. Twice. Two. Okay? This is, we are talking about the degree of a relationship. So if a relationship could relate to, the most common is to relate two entity types together, we call this a binary relationship. But is it possible that we relate more than two relationships together? This is the question. Give example.
Branch has staff, and staff lives in, for example.
Lives in where? But this is a different relationship. It's something like you do something like this. Because it's down, so let us draw an up. This is a different relationship. This has a relationship, lives in a relationship. Now we are talking about a relationship that relates many entity types together. I give you an example. A supplier, Morid, sends those parts to a project. So now the shipment, this shipment order, says what? Or relates what? Relates the supplier to the parts he ships, to the department or to the project he ships to. Now those are three entities that are tied together through a single relationship. But the relationship is, how can I draw a relationship using a single line? We have three entity types, not only two. So this is something difficult. Anyway, this relationship of three entity types, it has a degree of 3. Its degree is 3, or we call it ternary. So it's binary. Binary if it has two, it's relating two entity types. Ternary if it relates three entity types. Quaternary if it relates four, and so on. I prefer to use binary and a higher degree. Two names. Either it is binary, relating two entity types, or more, let's call it higher degree. So this is called the degree of the relationship. The number of entity types that the relationship, this specific relationship, tie together. The number of entity types it ties together. It relates together, okay? But the problem is how to draw. We call the ERD is a diagram. So how to draw? We used to draw a line for the binary. Line works very well for the binary, right? Because the line have two sides. But how can we draw any higher level, ternary or quaternary or whatever?
You can make it in the middle.
We need to use a different symbol. So we used the box, the rectangle, for the entity types. We use the oval for the attributes. We use the line for the relationship. Not all types of relationships, not all orders all degrees of relationships, but only the binary. We use a different symbol. We are going to use the rhombus. معين. Rhombus. Okay. So, for example, in this simple ERD, we say that registers is a relationship. The verb again, Verb. It relates what? It relates the staff, the branch, and the client. So it says, for example, the client registers in a branch with the aid of staff. So the registration here is a relationship that relates the branch, client, and the staff, or actually the client to the branch he registers in, to the staff who helps him to do the registration. Got it? So we use the rhombus when we have a higher degree relationship, a relationship with a degree higher than 2. سؤال ماشي طيب excellent. Here is another example for quaternary relationship for maybe 5, maybe 6, any other, but it's a symbol that we can use. It doesn't have to. You don't have to link to the corner. You can link to whatever, but it says that this bulk here, this box here, this rhombus here, relates all of those connected to it together. Got it?
It has to be like this shape.
Yes, it has to be a rhombus. My end out. Okay. So we talked about relationship types, one to one, one to many, many to many. We talked about relationship degrees, right? Degrees, binary or higher degree relationships. In order to understand this, let us have examples, 2 examples. This is the example supply that I just described. We have the supplier who supplies these parts to that project. Of course, the relationship here may be 1 to 1, 1 to 1, or 1 to many. It doesn't matter. So we say that each supplier supplies those parts to this specific project, for example. Okay. The symbol rhombus is used for three reasons. Not only for representing the higher degree relationships. Of course, we use it for higher degree relationships. But is this, when I see a rhombus directly, I would infer that yes, I have a higher degree? No, it doesn't matter. It's not necessary. We use this same symbol for one of three reasons, or the three together. It's either for higher degree relationships, we have understood this, or for many-to-many relationships. We said that, let us take the project, an example, this previous example here. This one, we said what? Let me draw it here. We have employee, and we have project, and we said that the employee relates to the project in many-to-many relationship, right? The employee works for many projects, and the project has many employees working for it. Project, not the department. Okay? This diagram here. Right? We can write it this way. But we are going to talk how to represent the many-to-many using the multiplicity in few minutes. But this is one way of doing it, and we write here many-to-many to say that these two sides are, this relationship type is many-to-many. We can do the same here. So has, every branch has many staff, right? But the staff works for one branch. Here we can write 1 to 1. This is how to write or to express the relationship type. So this relationship type says that the one to one, one to many, right? The branch, the single branch has many staff, and the one staff works for one branch, right? Here the branch, each branch has one staff, and each staff has is managed by one staff. You remember when we said we go to the trip twice, one from each direction, when we were talking about the informal description of data requirements, right? We wrote the relationship. This is the relationship. Branch is managed by staff, or staff managed branch, right? This is the title. Now we said let us go one step deeper. We said let us identify how many of this related to this, and how many of this is related to this. Why we were using this, why we were doing that, in order to identify the type. That's exactly why we were doing that. Let me explain it again. We go from here to here. So we say each one staff is what? Can manage, or may manage one branch. Each branch from here, each branch is managed by only one. So this relationship is 1 and 1. So when you go from here, you'll find that the staff is linked to only one branch. Here is the diagram. The staff is linked to only, we are talking about manage, okay? Manage here. The staff is linked to only one branch, and the branch is linked to only one staff, right? So we call this 1 to 1. 1 to 1. Here is the branch. Let's look at has. The branch has many staff, right? Same branch has many staff. So the branch has many staff. How can you read it? Branch has many staff. And the staff works for one branch. So this gives you an indication where to write the symbol. Because I'm going from branch, a branch has, then I read this before I go onto the stuff. So has many stuff. That's logical, right? And the stuff, each stuff, add stuff, has, and then I read this, one branch. Or actually it's not has, because has, we have to find another word for the other direction, works for. So has is equivalent to works for, and let's make it R.
Doctor, can you go back to the...
So so we are writing it at both sides to indicate the type, right? So back to the employee and the project. So it is what? M to M. An employee, let us say, works on. So an employee works on many projects. And a project has, for example, has many employees working for it. Right? Clear? So this is M to M. We accept writing this like this, one single line. But it is not preferred. Let us put this rule in between us, the convention between us. This is what I'd like to see in the exam. If it is an M to M relationship, to make it different, we are going to use this symbol. So this symbol is used for two reasons now. One for the what? Higher degree? The higher degree relationships with more than two entities interrelated, entity types of course, and also for the many-to-many relationships. These are two reasons. No, one-to-many and many, and one-to-many and one-to-one, single arrow is enough. So those are two reasons. Actually, we have three reasons for using this rectangle, this rhombus. What's the third reason? It's shown here in the diagram, in this example. Sometimes the relationship itself, like here, carries an attribute. We said that attributes are usually properties of an entity type, right? For example, here, supplier has a supplier name. This is an attribute for supplier. And it's underlined, means that it is the primary key for this supplier. Project has a project name, and again, it is the primary key. Part has part number, among many other attributes. Might have 10 attributes, but we are focusing only on the primary key because this is the identifier. Of course, we understand that there are many other attributes. So part has part number. Now, the supply relationship that links many entity types together says what? Says that let's try to understand this. Let us focus on this supplier relationship. This supplier S1, if you try to draw, this is a homework for you. Try to draw the occurrence diagram. The occurrence diagram for both examples. And see the difference. Okay? So supplier, let's assume supplier S1. Supplier S1 supplies the verb, the relationship, supplies project P1, or J, let us call it J1. Supplies J1 with part P1.
Or supply part.
So, but doesn't matter. Doesn't matter. You write it. Give the meaning. Just give the meaning. So S1 supplies P1 to J1, right? How many? How many parts? What's the quantity he supplied? When he supplied? The date, right?
How?
Maybe how? By air, by ship, by whatever, right? So, how many? Let's talk about how many, or the date. Does the date is an attribute, right? It's a slot to carry value. So it's an attribute. Where to place this attribute? Is it related to or describes the supplier? Does it describe the supplier? Why not? Because the supplier ships to many projects, has many shipments. Everyone has its own date, right? So which one, this specific date belongs to or describes which of these shipments, right? So I cannot consider it as far as a descriptor of the supplier. It's not a descriptor of the supplier, right? So let's ask, how about the parts? Is the date one of the properties of the part? Of course not, because this part is shipped many times, right? Many times. So which date is this? Same for the project. Project gets many shipments from different suppliers at different dates. But what? So where to place this attribute date?
The supply process.
Yes, exactly, because this describes it is one of the properties of this shipment. Supply or shipment, doesn't matter the word, right? So this shipment has or occurred at this date
So the date
with this quantity.
a property of supply.
Exactly. It's the property of the relationship itself. Property of the relationship describes the relationship. Got it? So this is the third reason of using this rhombus. So again, if you have a higher degree relationship, because the arrow is not sufficient to link more than two entity types. If it is a many-to-many relationship, if it carries an attribute. Okay? All the three reasons, or one, or any of them is sufficient. Only one of them is sufficient to draw the relationship using the symbol rhombus. Okay? Now we have understood the diagram, the ERD model number A. How about number B? What does it say? Of course, we are using here this symbol because it is many to many. Okay? So here, the supply here, let me use the pointer. The supply relationship here is used because it is ternary, right? Also because it carries
Properties or
an attribute. And if you look at the relationships, you will find that it is many to many. So for the three reasons, we draw the rhombus here for the three reasons. Now let us look at this. It is a binary relationship, right? The supplier supplies to project. So it's a binary relationship, but we have used the rhombus. Why? Because this relationship is many to many. How come? Why it is many to many? A project is supplied by many suppliers, and the supplier supplies to many projects. So this is a many to many. So it's preferred, and we will know why it's preferred next chapter. But let us agree together that we are going to use this convention. If it is many to many, we are going to use the rhombus. Although it is also possible to use the line. But a rhombus is more preferred than a line. And we will know the reason later on. So now we understand the supplies relation. How about the can supply and the uses?
another
Of course, they are many to many as well, So it says that this supplier can supply many parts, and this part could be supplied by many suppliers. The uses relationship, the project uses these parts, and this part is used by many suppliers.
Many projects.
By many projects, sorry. So the relationship is clear, understood, right? Please draw as a homework for your own sake, draw the occurrence diagrams for both ERDs.
Like this,
Yes, like this one, okay? It's more complex, but it gives you an idea how things are related, how occurrences are related together. But I'm giving these two examples. Note the following: we have the same the same entity types, right? Supplier, project, and part. Supplier, project, and part. Same entity types. But in the first model, they are linked or related by using a relation supply. It's a many-to-many relationship supply, right? While in the second model here, we have three relationships, not only one. Every two of these entity types are related using one relationship. Yeah, I mean every two, part and project are related using one relationship, and part and supplier another relationship, and so on. So the question would be, so these are two different models, right? Using the same entity types, right? But different relations. The question is, are those two models equivalent? In other words, does the many word that's represented by A is the same as the many word represented by B?
That's a little different.
They are different. In order to answer my question, you have to understand what's meant by equivalent. Equivalent means that they are modeling the same many words. In other words, they are able to answer questions about the many word, the same type of questions. They are able to answer the same type of questions. If there is one single question that could be answered by one of the models of A, for example, and not by B, then they are not equivalent. So every single question you ask the first model should be answered by the second model exactly the same answer. If this is the case, then they are equivalent. One single case is sufficient to say that they are not equivalent. So as a homework for you, and I need to discuss with you next time, are they equivalent? So try to find a question.
From now, I think.
Okay, go ahead.
Because, for example, if I said for a specific part, who can supply?
You are asking, okay.
Who can supply? In the first diagram, I can't get the answer.
You can get the answer. You can get the answer for this example, for this question, from both examples.
How in the first one?
Okay. In the first one, you go to the supply relationship, the occurrences of the supply. That's why I asked you to draw the occurrences. So go to the occurrences of the supply relationship and find
the point that
where it links to this specific part. You will find the supply relationship, something like this. Right? Every one of these is linked to 3. Right? One of them is here parts. So you go and find for the supply how many of those are linked to P1. You are looking for P1, right? So which of those is linked to P1? And then go and see which P1. This means that that P1, if suppose that this is P1, and this is also P1, and this is S1, and this is S2. This is P1 as well. P1, same P1. Okay, so go to P1, see what are the relationship occurrences. Now from these relationship occurrences you go and find who supplies, right? So that's why I'm asking you, in order to understand how this works, please draw the occurrence diagram and then try to find questions that are not answerable by both diagrams.
What supplies its what part it supplies?
What's it?
Yes. What I mean, for example.
What supplier supplies part?
No. What supplies which parts, for example?
The shipment.
Yes.
To make it simple for you, let's assume replace the word supply by shipment. Okay.
Okay.
Of course, it's better to use a verb, as we said, but it's simpler to use nouns.
What shipment it is chip?
Shipment is ship. What do you mean by?
I mean, what is the part that the shipment is shipping?
Which shipment?
Which shipment?
You are pointing to a specific occurrence. You have to point to a specific occurrence, right? For example, if you ask, the diagram down here says this supplier supplies to this project, but it doesn't tell supplies what.
That's what I'm talking about.
This
Yes.
diagram here says that this supplier S1 supplies to project P1 or J1.
What it supplies?
But what are the parts it supplies?
That's
I can tell what it supplies by looking at the other diagram. This S1 supplies to J1 this specific project, this specific part.
That's my question.
Yes, exactly. And not only that, you can say, what's the quantity? What is the date? And so on. So you can ask more questions. So, but please, again, draw the diagram. So this says that although we are using the same three entity types, but they are interrelated together with in different ways, this means that you have different model. Different model. This satisfies one many word. This satisfies another many word.
So they are not equivalent.
They are not equivalent. Homework for you. This is another diagram. Try to understand the diagram. Draw again the occurrence diagram for this ERD, and give me few examples, few questions. Few questions you can ask this diagram to get answers. And let us work together next time. Questions? Okay. Okay, shukran. Thank you.